Hello and welcome to this Python tutorial. Alright, so now in this tutorial we are going to implement the XGBoost model itself. So new code section here fitting XGBoost to the training set, so let's do it. So as I said in the previous tutorial, the first thing that we need to do is to import the right class for the job, which is called the XGB classifier class. As usual, it's going to be the same. We're going to create an object of this class that is going to be our classifier, and we will fit this object to the training set. So let's do it. First, we are importing the XGB classifier class from, of course, XGBoost, which we installed following the instructions on this link that we saw in the previous tutorial. So from XGBoost and then import XGB classifier. There we go. And now let's create an object of this XGB classifier class. So as just said, this object is the classifier. So we're going to call this object classifier as usual. And then we take our class XGB classifier and parentheses. And now something interesting. If I press Command I here, I get very little information about this XGB classifier class. The only thing we get is the list of the parameters we can input. And so as we can see, we have some parameters like the learning rate, as we had in deep learning, the number of estimators, because XGBoost is actually a gradient boosting algorithm with trees. So the number of estimators is actually the number of trees. And then we have some other parameters, but we're not going to play with those parameters now. This is only an introduction to this very powerful algorithm. But of course, you can find a lot of information on the internet. Don't hesitate to ask me and I'll give you some good reference. And also the second thing you can do is do a little practice and try to do some grid search parameter tuning, for example, to find the optimal parameters for some parameters like the learning rate or the number of estimators. You know how to do that now. It's exactly the same technique as how we did when we implemented grid search in the previous section. Well, that's great if you can do it. That will be excellent practice. But now we're not going to input any parameters. We're going to be satisfied with the default values here in this XGB classifier class. So we're going to take max step equals 3, 100 trees, and the rest is fine because actually we have a binary outcome. So the objective is binary logistic, and we keep the rest. You have another gamma parameter here that you can try to tune with grid search. Well, feel free to do whatever you want if you want to go further with this XGBoost model. That can only be beneficial for you, and don't hesitate to ask questions if you need any help while doing that. Okay, so basically our classifier object from the XGB classifier class, so we are ready to move on to the next line, which is about fitting this classifier object to the training set. So as usual, we're taking our classifier object, then dot, and then we use the fit method. Here it is, fit method, parenthesis, and inside these parentheses we input the training set, which is composed of xtrain and ytrain. And therefore, we input xtrain for the first parameter and ytrain for the second parameter. So xtrain is our matrix of features in the training set, and ytrain is our dependent variable vector in this same training set. Perfect! And actually, as simple as that, the XGBoost implementation is ready. That's actually exactly the same as when we implemented the other classification models. But of course, if you thought this was too simple, you can play with the parameters here and try to optimize their values. So basically we're ready. And now before we're going to execute, because I would like to do it the fun way, I would like to execute the whole code when it's ready. So we're going to add 3 more sections. One section to make some predictions on the test set, one section to make the confusion matrix, and one last section to apply k-fold cross-validation to get a relevant accuracy, a relevant performance metric to assess the performance of our XGBoost model. So next section is going to be the test set predictions and then the confusion matrix. So let's be efficient. Let's go to this ann.py Python file and let's go down and let's take the predictions and the confusion matrix right here. So I'm not only doing that to be efficient, I'm also doing that to show you how it is easy to jump from one template to another. For example, if you are doing some machine learning competitions, well, you can easily have several templates on your dashboard and jump from one another to take what's important for you. And so right now, that's what we're doing. We're taking the test set predictions and the confusion matrix codes. So let's go back to XGBoost and let's paste that here. We can actually remove this line because we won't get probabilities. We will directly get 0 and 1 predictions. And the confusion matrix is okay. And eventually, as I said, we would like to also get the k-fold cross-validation code to get a relevant accuracy of this XGBoost model. And so we're also going to this k-fold cross-validation. Once again, very easy to navigate inside the different templates. Here is the section. We just need to take it, copy it, and then go back to XGBoost and then paste it here. And here we go. Voila, our code is ready. Now what we only need to do is to execute it, and we can grab a cup of coffee and watch the results. So let's do it. I look forward to showing you that we're going to get some amazing performance in an instant execution time. So very quickly, let's go to File Explorer, to our folder, so Machine Learning A to Z, Part 10, and the last section of this course, Section 49, XGBoost. So again, congratulations for being here. Let's go inside. That's the folder. Make sure that you have the churn modeling CSV file, and if that's the case, you are ready to get your coffee and execute this code. So let's do it. Right now we are in the right folder. Let's start by executing the data preprocessing phase. So I'm going to select everything from here to the top, and let's press Command or Control plus Enter to execute. Here we go, all executed properly. So if we go to Variable Explorer, make sure that we have our data set well imported. So very quick reminder, this data set contains some informations of customers in a bank. The independent variables that we selected are all the independent variables from credit score up to estimated salary, and the dependent variable is this exited variable that tells if yes or no the customers left the bank. So that's during a period of 6 months, and during those 6 months we get a 1 if the customer left the bank and 0 if the customer didn't leave the bank. And so we're training this XGBoost model on this data set so that it understands the correlations between these informations like the credit score, the geography, the gender, age, balance, whether or not the customer has a credit card, is active, and the estimated salary, and the decision of the customer to leave the bank. And therefore, that's a classification problem in which we're classifying the customers between two classes, the ones that leave and the ones that stay. And then our goal is to make some predictions for the future customers and predict if they're going to leave the bank, yes or no. So let's press OK, and now let's move on to the exciting part. Let's fit XGBoost to the training set. So I'm going to first import the XGB classifier class, and there we go, the XGB classifier class is well imported from XGBoost. Alright, and now let's fit our classifier object to the training set. So we're going to select these two lines here. Let's execute. Here we go. The classifier object was created and fitted to the training set, and all the default parameters were selected. So for example, we have 100 trees in our XGBoost gradient boosting model. Alright, and now let's make the test set predictions. So I'm going to select this line and execute. Here we go. So that's the predictions of the decisions of the customers whether they leave the bank or not in the test set. So we get our predictions here. That's the predictions made by XGBoost. So for example, the first customer is predicted not to leave the bank, and the sixth customer is predicted to leave the bank. Okay, but that's not the most interesting. the first interesting thing is to get the confusion matrix, because we'll get a first idea of the accuracy, but then we'll get the relevant accuracy. So let's start by getting the accuracy from the confusion matrix. Here we go, executing this. The confusion matrix is here. We can see that we have a lot of correct predictions. We have 1,521 correct predictions of customers that don't leave the bank, and 208 correct predictions of customers that leave the bank. And then we have 197 plus 74 incorrect predictions. So since we have 2,000 observations in our test set, and since we have 1,521 plus 208, that is equal to 1,729, well, let's compute the accuracy real quick. So the accuracy is the number of correct predictions, that is, as we just said, 1,729 divided by 2,000. Here we go, and we get an accuracy of 86%. But that's not the most relevant accuracy. To get the most relevant accuracy, we need to apply k-fold cross-validation. So that's what we're going to do right now, and let's hope that we get this good accuracy, 86%, as the mean of several accuracies that we compute through k-fold cross-validation on different training folds and test folds. So let's find out about this now. This is a k-fold cross-validation with 10 folds, so that means that we'll get 10 accuracies, and then as you can see we take the mean of these 10 accuracies as well as the standard deviation to have an idea of the variance, and so indeed this is much more relevant. Alright, so let's execute this section. Here we go, taking 1 second or two to execute, and eventually we get a standard deviation of 1%, and the accuracy we need to recompute it. Spider just wanted to keep the suspense until the last second, but we're going to get the mean right now. We just need to execute that. And here we go. We get a mean of 86%. So that clearly means that the accuracy of our XGBoost model is around 86%, because not only we get a mean of 86% over 10 train test folds, but also we get only 1% variance. And therefore, in most cases, the accuracy will be between 86 minus 1%, that is 85%, and 86 plus 1%, that is 87%. So clearly, we get a very good accuracy, and besides, it's very difficult to improve it, because as we said before, it is limited by the problem itself. Well, you can try, for practice, to do some parameter tuning with grid search to optimize the values of the different parameters in the XGB classifier class, but I doubt that you'll get a much better accuracy than this 86%. Maybe you'll manage to go a little higher. Well, actually, I'm very interested to see what you can obtain with parameter tuning, so don't hesitate to do this as a homework, just for practice, and besides, you know, that gives you a good tour of many techniques we learned, and you do some parameter tuning with grid search. So, very good practice. I strongly encourage you to do this. And now it is time to say goodbye, because this was actually the last Python tutorial of this course. So that's quite a feeling, because this is the end of this machine learning journey that I introduced in my very first tutorial of this course. So yes, that's right, that's the end of the journey. However, I am sure this is not the last machine learning journey. This is your first machine learning journey. I was so happy to take this adventure with you. I really enjoyed that journey. I hope that's the case for you too. And I'll be very happy to make some new machine learning courses to start some new machine learning journeys. So I hope I'll see you very soon. And until then, enjoy.